True. Feynman, the guy who helped crack open the atom, won a Nobel Prize and could basically outthink anyone who ever walked into a room. Spent his entire life obsessed with one single experiment, not because it was complicated, because it was impossible. And that experiment quietly proves that the solid, dependable, true, boring world you're staring at right this second does not exist the way your brain thinks it does. The craziest part? This isn't some theory somebody dreamed up on a whiteboard. The math checks out every single time. So here's what I want you to do. Stick with me for the next few minutes through, because by the end of this, you're going to understand why one tiny particle acts like it knows when it's being watched, and why that one weird little fact basically detonates everything you assume is real. Oh, and the twist in the middle? That's the part that broke Einstein. Let's get into it. Picture this. You've got a wall with two thin slits cut into it side by side. Behind it a screen. Now imagine you're firing something at those slits, let's say tiny paintballs. What happens? Easy. Some go through the left slit, some through the right, and you get two stripes of paint on the screen. Two slits, two stripes. That's how the normal world works. That's how everything you've ever touched works. Now let's swap the paintballs for electrons. Tiny little pieces of matter, way smaller than an atom. You'd expect the exact same thing, right? Two slits, two stripes, fire away. Except that's not what happens at all. Instead of two stripes, you get a whole buttload of stripes. Light band, dark band, light band, dark band, smeared across the screen. That's not what particles do. That's what waves do. When two waves overlap, they interfere. Crests stack up and make bright spots. Crests and troughs cancel out and make dead spots. Same pattern you get when you drop two stones in a pond and the ripples cross through. So the electrons are waves now? Okay, weird. But scientists figured, fine. Maybe the electrons are bumping into each other on the way through, crowding, jostling, making that ripple pattern. Reasonable guess. So they slowed it down, way down. They fired the electrons one at a time. Single electron. Wait. Fire the next one. Wait. Through. There's literally nothing in there for it to bump into. It's completely alone. And here's where your brain should start itching, because the barcode pattern still shows up. One lonely electron going through a wall with two slits somehow interferes with itself, as if it went through both slits at the same time. As if it took every possible path at once. Read that again. A single particle. Two slits, both, at once. So obviously the scientists lost their minds a little, and they did the only sane thing left to do. They decided to cheat. They put a tiny detector right next to the slits. A little camera, basically, just to catch the electron in the act and see which slit it actually goes through. Simple, right? Just look. And the moment they looked, the barcode vanished. Gone. Just two stripes. Two slits, two stripes, like paintballs, like a normal, well-behaved particle. The electron only does the freaky wave thing when nobody's watching. The second you check on it, it snaps back into acting like a regular chunk of matter. Turn the detector off, barcode comes back. Turn it on, two stripes. Off, barcode, on two stripes. Single time. Now let's kill a myth real quick, because the internet loves to butcher this. This is not about human brew. The electron doesn't feel your eyes on it. It's not shy. Watching here just means measuring something off it to grab information. But honestly, that's more disturbing, not less. Because it means the universe has a rule baked into it. The instant you pull out information about which path a particle took through, it stops behaving like a possibility and starts behaving like a thing. Sit with that. Reality seems to depend on whether or not information got out. That's the experiment. And most physicists at this point just kind of shrugged and said, yeah, it's weird. Don't think about it too hard. But Feynman didn't shrug. Feynman looked at this thing and basically said this single experiment holds the only real mystery in all of quantum mechanics. Everything else is just details. And instead of running from it, he did something insane. He gave it math. Here's the idea, and it's genuinely one of the most beautiful thoughts in all of physics. Feynman said, stop asking which path the electron took. Wrong question. Instead, assume the electron takes every possible path, all of them, at the same time. The straight path, the curvy path, the ridiculous path where it loops around the moon and comes back. Every single route from start to finish, happening all at once. And then you add them all up, like waves stacking on a pond. And whatever survives the pile-up is what you actually see. He called it the sum-over-histories. The electron doesn't have one story. It has all of them, layered on top of each other, and reality is just what you get when you add up the infinite pile. That's the math. And it works so ridiculously well that we used it to build the technology in the device you're watching this on right now. Lasers, transistors, your phone. All of it runs on the assumption that reality is a sum of possibilities, not a single solid thing, okay? Take a breath. Because you think it can't get weirder than a particle taking every path in the universe at once. It can. It gets so much weirder. Here's the twist. Scientists asked a devious little question. What if we wait? What if we let the electron go all the way through the slits, past the point of no return, and only then decide whether or not we're going to look? The electron's already committed. It's already through. The choice comes after. So it must have already decided whether it was a wave or a particle before we made our move. Right? True. It can't see the future. Wrong. They ran it. It's called the delayed choice experiment. And when they held off on the decision until after the electron passed the slits, the electron still matched the choice. Look late, 2 stripes. Don't look, barcode. It's as if the electron reaches backward in time and rewrites what it did through, based on a decision you hadn't even made yet when it happened. The present seems to edit the past. At this point, you're probably feeling that little spike of, okay, this has to be fake. It's not. This is textbook, Nobel level, replicated 1,000 times physics. And it led straight into the biggest fight in the history of science. In one corner, Einstein. Einstein hated all of this. Hated it. He famously grumbled that God doesn't play dice with the universe. He refused to believe a particle had no definite reality until you looked at it. He basically asked, you seriously think the moon isn't there when nobody's looking at it? There has to be something we're missing. True, he said. Hidden information, secret variables the particle carries around that decide its fate in advance. So reality stays solid and real even when we're not watching. For decades, nobody could settle it. It felt like philosophy, untestable, just 2 camps yelling across the room. True. Until a physicist named John Bell did something Einstein never managed. He turned the argument into a number. Bell worked out that if Einstein was right, if particles carry hidden, preset instructions and the universe plays by local common sense rules, then experiments could only ever produce results up to a certain limit, a hard ceiling. True. But if quantum mechanics was right, the results would blow straight past that ceiling. So now it wasn't philosophy anymore. It was a measurement. You could actually walk into a lab and check which universe you live in, and they did, over and over, for years, with tighter and tighter setups. Alan Aspect, John Closer, Anton Zeilinger. The 3 of them ran these experiments so cleanly that in 2022 they won the Nobel Prize in physics for it. And the verdict came back, loud and final. Einstein was wrong. The results smash right through Bell's ceiling. The particles do not carry secret preset instruction. There is no hidden script keeping reality solid behind your back. So here's the big reveal, and I want to be careful and honest with you, because this is exactly where people go off the rails. It's not that nothing is real and you're living in a video game. That's the lazy clickbait version. The truth is stranger and cleaner than that. What the math proves, what Feynman spent his life pointing at, is that the universe cannot have both of these things at once. The idea that things have definite properties before you measure them, and the idea that nothing sneaks faster than light to coordinate them. One of those has to go. Reality, at the bottom, does not work the way your brain desperately wants it to. Particles genuinely don't have a settled here or there, a definite this or that, until the universe forces the question. The solid world isn't a lie, it's an average. It's what you get when you zoom out far enough that the infinite pile of possibilities blurs into something that looks dependable. You are made of things that up close are more like a fog of maybe than a set of tiny, solid balls. And Feynman's real genius wasn't proving reality is fake. It was proving that reality is honest about being uncertain, and then handing us the exact math to predict that uncertainty down to a mind-numbing number of decimal places. He looked at the one thing in the universe that refuses to make sense, and instead of looking away, he wrote its equation. So next time someone tells you the world is simple, solid and obvious, remember the electron. Remember that it went through both slits, took every path in existence, and changed its mind the second you tried to catch it. That's the reality you actually live in. If your brain is a little bit melted right now, good, that means you were paying attention. Do me a favor and drop a comment. Do you think the moon is there when nobody's looking? I read every single one. If this rewired something in your head, smash that like button and subscribe, because we go this deep every single week. I'll see you in the next one.